I'm Henry Carter. I am the project manager for AS Engineering, and this is our first progress presentation of the semester. Today, I'm with Carly Sheen, our transportation engineer, Darius Lane, our structural engineer, and Francesco Messina, our environmental engineer. I think I forgot to mention, I'm also our water resources engineer. So the goal for our project this semester and last semester, I guess, has been to design the reconstruction of a portion of the County Road 38 corridor along with the intersection with County Road 21. We need to construct a visitor center, an adjacent parking lot, a wastewater treatment facility, and a stormwater treatment and management system. Now I'm passing on to Carly.
Thank you, Henry. So as Henry said, I'm the transportation engineer for AS Engineering, and just a little quick overview of what I was tasked to complete for this project. I was tasked to realign County Road 38 with a multi-use path along the south side of the roadway and a 3-lane section on the eastbound approach of the intersection. I also was tasked with redesigning the intersection of County Road 21 and County Road 38 with the proper pedestrian facilities, and also a parking lot for the new visitor center. And I also have to design a path underpass for the path underneath the bridge on the eastern end of the roadway, tying into the existing path and reconnecting the road to Kircher Road. For my design constraints, for my design speed and my design vehicle, they were given to me by the client, and they are 45 miles per hour in a WV67 vehicle. For my minimum and maximum grade of 0.5% and 4%, those are both provided by the Indiana Design Manual, Figure 53-2. For my minimum curb radius of 125 feet, that was provided to me by the Indiana Figure 46-2D. And my minimum radius for my horizontal curve of 587 feet was provided by the AASHTO Green Book. For my typical section, I had a normal HMA crown with 12-foot lanes and 12-foot paved shoulders. For my mainline pavement, I had 1.5 inch of surface, 3 inches of intermediate, and 6 inches of base. For my paved shoulders, I had 1.5 inches of surface and 3 inches of intermediate as well. For the roadside ditches, my water resources engineer and I went with a 4-to-1 slope for the IDM Figure 53-2 requirements, and the 10-foot multi-use path on the south side of the roadway was a 1.5% slope per the ADA requirements. For my intersection, jumping back to last semester, I determined that a 4-stop intersection that was signalized with dedicated right turn lanes for each approach was the best option for this intersection, and the multi-use path stretches along the south side of the roadway and reconnects into the pedestrian refuge islands, and then will cross on the northeast side of the roadway per the scope that was provided. For my horizontal curve, I chose a realignment that closely mirrored the existing roadway, and I had a horizontal curve radius of 730 feet that best fit the roadway. For my parking facilities, I went with a parking lot with 131 stalls, with stall sizes of 10 foot by 20 foot, which was a conservative size, and 6 accessible stalls, all with access aisles. And my my trash facilities are located in the top left corner of the parking lot. For my maintenance of traffic plan, I chose to break up my plan into 2 phases because I felt that closing down the intersection and the length of the roadway might be a little bit too much for the surrounding neighborhoods and the businesses in the area. I also had the option of rerouting traffic back down to County Road 21 into the adjacent county road, but I didn't want to get in the way of the Goshen Junior High School and all the homes in this area, so I chose to just keep the path along West Plymouth Avenue. For my construction costs from last semester, I had a construction cost of $2.9 million with a 35% contingency plan, and this was using the INDOT unit summary Excel spreadsheet. For my future work, I need to fix up my cost estimate and then also design my pedestrian access to my visitor center along with my curb ramps for my pedestrian facilities, and design the path underpass that will stretch underneath the bridge. I'll now pass it on to our structural engineer, Darius Lane.
So as mentioned, I am the structural engineer for AS Engineering. Just to get a quick reminder of my project scope, I had to design a 2-story visitor center and I had to make sure it was about 40,000 square feet with an additional attached 1,200 square feet for an outdoor covering area, and that was actually attached to kind of my food court area. So just giving a preliminary structural overview of my floor plan, this is what I currently have here. So you have my ground floor, my first floor pictured here. So you can see, as I mentioned earlier, my food court was what's attached to my covered outdoor seating area. And then I had a total of about just a little over 40,000 square feet, so keeping it relatively close to the given scope. And then my additional, I kept it to exactly 1,200 square feet. Looking at my structural framework, this is covering what will be that first floor. So quick overview is just the masonry walls. I have the 12-inch thick exterior walls to be the low drain walls, and then for the interior low drain walls to just be 6-inch interior walls. And then my timber floor supports will be a variation between the beams and joists, just given the variation of whatever the analysis may be from RISA, depending on the different spaces, as there are a lot of variations with my spaces and it's not very uniform across, so it just really to be down to the point where it be needing beams or joists. So just now moving on to kind of my area loads and what's given here. I decided to choose the public loading area because based on my floor plan, on that upper floor is a lot more just kind of open space and stuff as the offices will take place mostly on that ground floor, so there won't be needing to kind of assign it in any other way. So my masonry walls are kind of currently spaced between 20 to 40 feet depending on the type of spaces I have. And my timber floor support, where each of the beams and possible joists are currently spaced at 10 to 12 feet apart from each other within those areas. And then just moving on to my area loads given through RISA floor, my public occupancy load, and so the live load is about 100 PSF, and then the dead load currently is at 10 PSF, and that is not including the composite decking that I will be choosing, so that's in my future work. So my current cost estimates from last semester is about 8.15 million. And so this is given from the RS means square foot estimator. And then just moving on to my future work, I will have to just finalize my framework analysis for the first floor in RISA, and then with that I can move on to getting my roof load. And I'm moving on to I'll be designing it based on a flat roof. And then I'll transfer the analysis into RISA 3D to calculate more of those lateral wind loads where RISA floor can only give me the gravity floor loads. And moving on to my calculations, which will be used to check anything that RISA gives me based on that analysis. And then the cost estimates I'll be using through RS means to get more of those line items that I'll be using for the construction costs that I'll be able to kind of get a more accurate view of that, as if the square foot estimator isn't as accurate to, as I had to use kind of what would be a simulation of what I would actually use versus what I am going to do. So yeah, I'll move on. That's on Francesco.
Hi, I'm Francesco, I'm the environmental engineer at AS Engineering, and for this year I was tasked with creating a wastewater treatment plant consisting of primary, secondary, tertiary treatment, as well as disinfection and a disposal structure. With this, there's an average flow of 1 million gallons per day, and the use of the latest treatment technologies must be in compliance with all local and state regulations. Today, I'm just going to be looking at the primary treatment and the pre-treatment aspect of this design, as I have the CAD and the overall design for these. Just as a recap, the alternative I chose was the membrane bioreactor, and specifically we're looking at the pre and primary treatments, which would consist of the bar rack, the fine screen, splitter box, aerated chamber, and the primary clarifier. Just for the flows of the whole system, I have this process drawing showing the influent at the top over here coming in, going through 2 sluice gates to divide into 2 different bar racks. From that, a similar design is using 2 sluice gates to divide into 2 different fine screens. Both of these use the redundancy, as they would use 1 channel, but you want to have 2 just for maintenance and operation. From this, they're splitting the flows from channels into pipes using a splitter box, into 2 separate aerated chambers, which also use redundancy. The flow then continues to the primary clarifier, which uses type 2 sedimentation to settle out some of these solids. First step is the bar racks. These bar racks are located outside, and following the design of the sluice gate, which divides them into 2 different bar rack channels, introduced through a flume and a sampler. These bar rack channels are 5 feet wide, 3 feet deep, 0.6 inches in width for each bar, and 0.8 inches for each spacing. I understand that these are not something that a contractor would look at. This is just a conversion from metric to imperial. So further down the line, I'll be tuning up these values to be more adequate for contractors. The bar rack will consist of 45 bars, 46 spaces, a through velocity of 2.5 feet per second, and approach velocity of 1.5 feet per second, using the peak hourly flow rate. The fine screen is a similar use. The difference is that it's indoors, as it's more prone to weathering. So this takes the solids, puts them on a conveyor and into a dumpster. The dumpsters will be emptied 2 times a week, but as it is indoors, you need some overhead doors to allow the dumpsters to be moved outside and put into different trucks. I used a aerated gear chamber for my gear chamber, and the volume is 1,250 feet cubed with a depth of 6.5 feet, width just over 8 feet, and about 23 feet long. It has a bottom flow velocity of 1.37 feet per second, and the depth of your channel is 1.57 feet. The flow goes in a molecular motion throughout the tank, allowing the solids to drop out. You can see this in this next image, which shows the molecular motion, so the solids dropping out to the bottom of the channel. The 1.5 comes into the bottom of this height of the channel here, and you can see the air diffuser on the left, or on the right side, pumping into the air. The flow then continues into a splitter box to split the flows into 2 different pipes to travel to the 2 different primary clarifiers. Length of the weir for this is 1.32 feet, and a weir plate of 2.62 feet. The overall depth is 6 feet, with 2 feet at the top just for the flow to overtop the weirs. The large diameter of the inlet is 1.5 feet, with 0.5 feet for the effluent continuing onto the primary clarifier. Lastly, I have my primary clarifier using a typical drawing. This is the diameter of the feed well is 15.72 feet. The feed well just allows for the distribution of the water and the solids to flow evenly on each side. The diameter of the energy disposal inlet, the purpose of the energy disposal inlet is just to slow down the flow once it enters the clarifier from the bottom. They have a sidewall depth of about 10 feet, and half of that as guidance from the Water and Wastewater Engineering Practice and Principles book, 5 feet. And the sledge hopper height, which collects the sludge at the bottom, is 4 feet. For a better look at this, using an image from Minco Engineering, or Environmental, see the sledge hopper at the bottom, the bar that goes across and scrapes it from the bottom into the disposal, as well as the flow entering from the top. This EDI to slow down the flow, the depth of the feed well over here to allow for distribution, as well as the skimmer arm and the scum bin right here to collect oils and wrappers at the top. This allows also for the water to flow over the scum baffle, over the V-notch weirs, into the effluent on the outside, moving on to the next step. Here's a top overview just to get a overall look at the clarifier. The clarifier is 29.5 feet wide with a 2-foot diameter of EDI, and then again, the hopper width of 4 feet. From this, I will continue my future work on the CAD drawing for the secondary and tertiary treatment, as well as the disinfection. And I want to continue the calculations for the plant piping, as well as confirming the selections for each of the plant processes. And I want to update my cost estimate, as I have a current cost estimate of $7 million, but that is using RS means. I want to use something like the EPA cost estimate to get a more refined cost estimate. With that, I'll turn it over to Henry Carter.
So for the water resources portion, we have 2 primary objectives. We have to address a flood control volume and a water quality volume. The flood control volume for this site is going to be the runoff from the 100-year 24-hour storm, and we need to discharge that into the Elkhart River watershed according to local regulations. And the water quality volume is the first 1.25 inches of runoff of all impervious areas, and we need to reduce the nitrogen loading in this volume by 50%. And the water quality volume is within the flood control volume, if that makes sense. So to achieve this, I have 3 stormwater BMPs, I have rain gardens, underground storage, and saffle baffles. All these I will be talking about in depth shortly. And auxiliary components just help with the conveyance of water. I will have roadside ditches, culverts, and storm sewers. I'll also talk about this shortly. This is just a diagram or overview of the site area where everything's going to be. All water flow through roadside ditches are going west to east to the river, except for over there. The storm sewer is going to be flowing east to west on the east side of the river. This rain garden right here is going to be gathering all of the runoff from the building and parking lot areas, and that's the one that will be treated and then returned back into the roadside ditch, and then all of that will flow into the underground storage, then be released appropriately into the river. So the first component I'm going to talk about is the rain garden. Like I said, this contains or collects all the water from the building and parking lot areas. Water flows fills into the top and goes down through these zones. Then we have a nitrification zone and a denitrification zone, or an oxic and anoxic zone. What this means is as the stormwater runoff goes in and infiltrates these soil layers, ammonium will convert into nitrate and nitrite in this nitrification zone. And then as the water then goes down through here, that nitrate and nitrite will then go through a couple of stages and then eventually become nitrogen gas and be released into the atmosphere. And the treated stormwater can move on throughout the system as planned. To achieve this, the ideal soil mix to create these conditions and create the proper level of infiltration rate is coarse sand, compost, and native topsoils. And the capacity for this rain garden is approximately 63,000 cubic feet, and the amount of water that will be treated is just over 36,000 cubic feet. Oh, additionally, the infiltration time is 33 hours. That is the amount of time it takes for this ponded water to go into the soil. That has to be less than 48 hours. So this design works. We have a pretty typical roadside ditch going throughout the length of the road. Specifically, it's classified as a natural channel, earth, straight with some grass. These are the dimensions and parameters for my ditch. The ditch is being really over-designed for 90 cubic feet per second. It will only ever see approximately 3 cubic feet per second at the peak flow rate. The reason for this is for the culvert I designed at the top, it has to have 2 feet of backfill between the top of the culvert and the bottom of the roadway. So in order to get it deep enough, the ditch has to be really deep, and it can support a lot of extra capacity that way. This is the culvert that I briefly mentioned. Nothing super spectacular about this other than 1.5 diameter corrugated aluminum pipe, 86 feet long, and they said about 3, so 2.9 cubic feet per second. This was generated in HY8. The last BMP that we're going to talk about is the underground storage. The reason I chose underground storage is because it acts similarly to above ground storage, retention or detention ponds, and that it just collects water, holds it, and controls the discharge rate. But for underground storage, I chose R-Tank manufactured media blocks. And the reason I chose this is because you can bury it and minimize the footprint, the above ground footprint, and it satisfies NDOT Type 2 structural backfill, so you can build roadways and small structures on top of it. So ideally, you will not be able to see this, and it is safer because you don't have to worry about people falling into a pond. The capacity for this is just over 21,000 cubic feet, and through level pool routing, I found the max storage of water that will be in at any given time is about 17,000 cubic feet. Then on the east side of the river where the storm sewer system is, there's not a lot of footprint to do a lot of actual treatment, so I'm just putting these SAFL baffles into the inlet structures, and what they do, you can kind of see this is without a SAFL baffle. This has a SAFL baffle in a lab test, and it just stops the scouring and flow movement within the structures, so it allows solids that are suspended in the water to settle more. You can almost see kind of a circular rotation there, picking up solids, and over there it is settling nicely. So that's just going to act as pre-treatment before it enters the river. For my future work, I need to design the actual storm sewer system, because I have not done that yet, and I need to calculate the construction cost for my portion of the project. That will be all. I'm sure there are questions, but any questions?
So, questions for you. For your mix of your rain garden or bio retention basin, whatever you call it,
Yeah, the sand, compost.
and native topsoil, is that all mixed together? And then what's the ratio of each?
The ratio, I do have percentages.
Okay.
It's mostly coarse sand. I think it's like 55% coarse sand, and then the others are put in there. I don't remember off the top of my head. It's an EPA document
Okay.
that talks about it. And that's just, the reason I chose this is because for nitrogen loading, I need specific infiltration rates. And so that achieves the specific infiltration rates, and the native topsoil somehow helps with the activation of the vegetation denitrification.
So are you using shredded newspaper also?
I'm not, John actually bought all of it, so.
So what is your carbon source?
I do not have a carbon source other than what's in the native topsoil, I guess.
The compost.
Or compost.
Probably.
Yeah, there's my carbon source.
And then the last question is, for your, since your ditch is so over-designed, can you turn it, is it native vegetation in there? Can you turn it into like, basically, get much more water quality treatment? Right, if you put vegetation in, and is it just gonna be grass, or is it like?
Just having some grass?
Yeah, you can have, you got the capacity to really slow that water down, increase infiltration.
I'm really sure we could.
That'd be worth
Good
it.
idea.
Yeah.
But on this picture, before we go off that one, because this is so over-designed, you're gonna end up buying what appears to be a lot of right-of-way for nothing. Not for,
Yeah.
for no reason, lots of cost. Perhaps you need to look at the clear zone, if you just, there's a 45-mile-an-hour speed limit.
Yeah.
So by the time you get off the end of the edge of pavement to the beginning of the slope going down the ditch, you're probably already outside the clear zone, so the back slope of that ditch can be a lot steeper, like a 2-to-1 or a
Yeah.
1-to-1, even if the earth will hold. So you might want to look at
Yeah.
that just to kind
Cut
of
down
narrow
some
your
costs.
cross-section up a little
Yeah.
bit.
It's a good idea. We'll have to look at that at some point.
Mm-hmm.
Well, Henry, I did not buy your logic about the deep ditch in here, because you can have it at a steep slope and use energy dissipation to meet the elevation of your product.
Well, there is that, but it's almost 9,000 feet long, and so if you have, and the ground elevation is, it's like a 0.12% slope average, and so if I used a steeper, maybe I'm misunderstanding your question.
Well, I'm saying you can have it flat most of the time
Mhm.
and very shallow. And then at one point, you could either step it down, or you can have it slope with energy dissipation as you approach the culvert.
Okay, yeah, that is true, but the slope is very gradual, other than at the end, so if I did that in the culvert right here, I would not be able to then get the moment, it'd be too deep to then get into the underground storage at the top where I need it, I believe.
I mean, for the reasons being mentioned in here is, it seems to be like impractical in here to have it the way you are proposing it. But I'll leave it out, I don't know the details. The same for your underground storage. Is that came out to be your best alternative from the previous semester?
Yes, it did.
Just gotta let it dry.
The reason is because previously I had a couple above ground alternatives. Where do I go back to one thing actually? Right through around here, but that is where Francesco is building his wastewater treatment facility. And then, so my other options were over here, which would have then had to design other culverts or ditches, and I did not want to do that because it's not as practical if I could just use this underground storage alternative.
I'll tell you up front, I'm not buying your story looking at all of this vacant lots along the road in here. I mean, that's gonna be very expensive if you put it like underground compared to, that's the first one. And there will be challenging putting that underground under the road in there.
And then I guess my other thinking there is when we have the underground storage, the outlet's in the bottom. If we do it over here and the outlet's, 6 feet underneath the inlet, or let's say 6 feet, then how do we get it back up to be able to flow down without using pipes? So right here, there's almost an 8-foot drop within just a couple feet, because there's already an existing pond there, as of now. And so if we just outlet it, then we can just outlet it into that marshland, which will flow into the river.
We'll go along in there. But, Francesco, I was amazed with how accurate your split box dimensions are. You wanna go to that?
What about it?
What is- Look at these like four.
Oh, you're talking about them on the zeros?
Yes. Okay,
Very particular.
I'll leave it there.
Exactly.
So I got a couple of questions, one for environmental. So you have it situated kind of toward town, right?
Yep.
And right now it is drawing just the wastewater from
Visitor
the
center.
visitor center. So is there capacity to have other development attached to it? Or
You mean like expansion, if it would
Like
if it was more than the visitor center? Yeah.
or what would that take? I mean, would it be possible in that same location? Because you're mentioning like limited space or things like that.
Yeah, well, I see Henry's is over here. Mine's more towards this side, so I have a bit of space over here as well that I can expand. Obviously, they would have to use some bypass piping if they need to expand the tank or add another tank. But yeah, they should be able to expand that if necessary.
Okay. And then we'll go back to your ditches. So, when you can keep that plan, that's, I guess,
Just kind of look at it.
the long one. So you have ditches running on each side,
Mhm.
and the road profile hasn't changed too much. But who's responsible for kind of the smaller culverts or piping, for all the access roads, right? You got all the access roads on one side coming into the road.
You talking about all of these driveways and stuff like
Yeah.
that was outside of our scope of design.
So, but if you do like your larger ditch throughout, once you have to really maybe redo
Yes,
all of these.
yes, that was a question. Currently, like, in the real world, they have an underground sewer system there, and so we asked about that because that is a lot of hindrance, and we were told to treat it as if those driveways were not there, just for the sake of our design and getting that across.
I think you were told to treat it like it was outside your scope.
Yes.
Not that they weren't there.
Yeah, that's what it is.
Sure.
Yes, treat it like it's outside of our scope. Paraphrasing.
Otherwise, it'd be all culvert. But
I'd still be working with culverts right now.
Carly, on your alignment,
Yeah.
you said, could you get that picture that shows the horizontal alignment? There you go. The horizontal curved radius of 730 feet.
Yep.
That's that one. How about the other one the same?
It is the same as
You
well.
got an S curve, okay, so both curves are that. Is there enough room between the two to finish those?
There is, yeah.
Okay.
Due to like the vertical alignment and everything, the slopes are all under 5% or over, under 4% or over 0.5%.
Yeah, but I meant that, can you finish the horizontal curve to the right before the one to the left starts?
Yes.
Okay. And you said the standard was 587 foot radius?
Yes. I know, I
Really?
also, I thought that was weird as well, but I also saw it in Ethan's presentation,
Yeah,
so that's in the
I-
Hashtag Green Book, which is the Elkhart County standards.
Even rounding it up 3 feet would have been fine for any, you know, they really did that though.
Yeah, I thought it was like a mistype, but there's other
I wonder
odd
if,
numbers as
yeah, I
well.
wonder if that's a conversion metric or something.
it's 179 meters, I just checked that, so it's not like some, yeah.
It's a weird number. Okay, thank you.
Are we there, yes? No, we're not gonna do it.
We just have to, we just have to end by 2:35, so we just.
Ask questions to
Don't let them
I guess you are unique in the sense you are designing like timber beams in here and girders.
Yes.
The thing is, I did not see any sizes.
Yeah, so I currently did not put in the size, it's still a work in progress. A lot of the results I came up with were purling, and I didn't feel like those were exactly ideal. So because I'm still working in progress with it, I didn't want to put it up there, as that's not what I want to stick with. So I was gonna go in exactly and do more detail with it and to look, say, I'm specifically looking for maybe joists for these kind of bigger areas and stuff like that, but those were a lot of the results. But the purling wasn't giving a lot of results that were ideal for me.
Yeah, my concern is how tall the columns you are designing or you input into RISA in this case.
So, how tall they are, it's about 16 feet, so each floor is
Okay,
about
so
16
you have
feet.
enough room space?
Yes.
Because I'm expecting the timber ones to be like deeper than like,
Yes.
we
Yeah.
saw last time, they were W something,
Mhm.
33, I believe, the deepest, like W section. And so expecting with timber, maybe it's gonna be a bit deeper, and so you wanna have enough space, like room head.
Yes, that's exactly my purpose in that is that I will be going a little bit deeper because I have pretty higher roofs on each floor, so. more
Because
clear.
others use like 12 feet columns in there. Okay, thank you.
Any other questions?
I got a question for Henry.
I'll remember that.
First of all, amazing job. If you go to the R tank, just a simple question. It's not nothing on your design. I just don't really know much about R tanks. So is that like the plastic shipping containers? You know, like what is that made out of?
It's pretty much just plastic.
That's what I
It's
don't
just
know.
Plastic. And
I
you
see.
stack 'em together like
Just like got
windows
holes
and-
in it? Is that okay?
Yeah.
All right, I'm good. I just didn't know what it was made out of.
Okay, any other questions? Okay, thanks.